Hello, my friends, and welcome, Mr. Pelly, and welcome to 6.3. So this is where the math went from crazy to a little crazier, to be honest with you. Some of the longest problems that we do are right here in this unit. Some of the hardest problems we do are right here in this unit. So grab your calculator, grab your periodic table, grab your notes if you're actually in my class. I printed off these notes and I gave them to you. So they were in the first part. So dig those in there. I know this is page, I don't know, like 6 or something like that. All right, so test 6.3, limiting reactants and excess. The words limiting reactant is identical to limiting reagent. They're used interchangeably. There's no difference. They're both used quite a little bit. Limiting reactants control the amount of product formed. They limit. What are they? They're reactants. What do? They limit. Okay. So if I own a tricycle company, my tricycles have 3 wheels for every 1 frame. How many tricycles can I make? Well, if I have 9 wheels and 2 frames, 9 wheels says 3 tricycles, 2 frames says 2 tricycles. How many tricycles can I make? 2. It's always the smaller. Okay? So that's important to know. You always make the smaller amount. So limiting reactant control, so in this case, wheels limits it. Okay. So limiting reactant controls the amount of product by converting each reactant into the product, and the smallest amount is actually made. Okay, so examples. So in an experiment, 3.25 grams of NH3 are allowed to react with 3.50 grams of O2. Find the limiting reactant. So this means we've got to do kind of sort of the same problem twice. So I'm going to convert my grams of NH3 I'm going to convert them into water because I know the molar mass of water. I'm going to convert both of those. Oh, no, I'm not. It says find the mass of NO. So see question number 2. So I'm going to convert them both into NO so I save myself a bit of time. Okay. So I'm going to start with just like what we've done before. Just a bit bigger. 3.25 grams of NH3. And remember, we're going into grams of no. My name is no. My number is no. The rest of that. And then grams of NH3 into moles of NH3, just like what we've been doing. Little g stands for grams, and little g stands for go to the periodic table. So I add up 1 nitrogen and 3 hydrogens to get 17.04. And then I'm in moles of NH3, and I want to go into grams of NO, but I first have to go into moles of no. My name is no. Okay, so I don't have any coefficients right now. So that tells me I better check to make sure that I'm balanced. So I've got 3 hydrogens and 2 hydrogens. Oh, man. Let's go least common multiple of 6. This gives me 2 N's. That'll give me 2 N's. This will give me, I've got 2 oxygens on the left, and I've got 2 5 oxygens on the right. I'm going to go crazy and just call this 5 halves. Okay. I can call it 5 halves, or I could do what you probably did if you're doing it on your own, which is double everything. I guess I'll go with the double everything. 4, I'm doubling everything. 5, I'm doubling everything. 4, I'm doubling everything. 6. So NO's coefficient is 4, and NH3's coefficient is 4. So it turns out it didn't matter that much. But we'll keep trucking on here. I'm going to get rid of moles of no, and I'm going to go into grams of no. So now I'm not going to use 4, I'm going to use moles. I'm sorry, 1 mole. So 14.01 is nitrogen plus 16 is 30.01 grams of no. So far, so good. I'm going to do pretty much the same thing, 3.50 grams of O2. I'll do the math here in a minute. 3.50 grams of O2. I hate you, grams of O2, so I'm going to cancel you and go into moles of O2, 32. And then I'm going to get rid of moles of O2, go into moles of no. My name is no. Yeah, you heard that before. It didn't get any funnier this time. And then coefficients for moles over moles. And then 1 mole of no. My name is, yeah, you get it. And 30.01 grams of no. One thing that's kind of nice is these final masses will be the same. So I'll run the numbers for each one. Top one, 3.25 divided by 17.04 times 30.01. I didn't do this because they cancel. I get 5.72 grams of no. And then over here I have 3.5 grams of oxygen divided by 32 times 4 divided by 5. times 30.01, and I get 2.63. So how much is actually, so first of all, find the limiting reactant. Oh, that moved a little bit. This is how much I made because it's smaller. The reactant that did that is oxygen. All right, so that's it. So limiting reactant is oxygen because it's the reactant that made the smaller amount. And how much was made? Smaller amount. All right. Next one. Reaction container holds this much of this and that much of that. Following reaction occurs. Oh, good, it's balanced for me. What's the limiting reactant for the formation of that? And what mass of P4O10 is produced? So I'm just going to do the same thing again. We should be really quite good at these because we just took a test on it. And it should be easy to roll. P4. Grams of P4. I'm going to go into moles of P4. Man, my pen doesn't like to make the number 4 today. So phosphorus is 30.97 times 4. 123.88 moles of phosphorus. What am I going into again? Mass, grams of P4O10. So moles of P4O10. Moles over moles use coefficients, 1 and 1, times 1 mole of P4O10, and grams of P4O10. So P4 was 123.88 plus quantity. Oxygen is 16 times 10. So 283.88. 283. And then I could do that number now, but I'm going to do the other one next. So here we go. The other one was 5.77 grams of O2. 5.77 grams of O2 times dividing bar, grams of O2, 1 mole of O2. There's 32 grams in a mole. I got moles of O2. I got moles of P4O10. Moles over moles use coefficients, 1 to 5. And then I'm going to have 283.88. Notice the molar mass is the same, so at least I don't have to do that again. And 1 mole P4O10. And then let's get our answers. So do the bottom one first. I don't know why. 5.77 divided by 32 divided by 5 times 283.88. I got 10.2 grams of P4O10. Top one, 5.77 divided by 123.88 times 283.88. And that's 13.22. Oh, man. So I think I might have had something wrong here because I have a little cheat sheet key there for that. So I'm going to do my numbers again. I'm going to check to make sure they're okay. Times 283. That looks right. 5.77 divided by 32 divided by 5 times 283. So I'm going to check my molar masses again. Check to make sure phosphorus is 30.97. So trust the old man brain. It is. Well, I'm going to roll with this. So this is the smaller amount. This is how much forms. What mass is produced? This is the answer to B. And my limiting reactant is the reactant that gave us that. Limiting reactant equals O2. If you can find where my mistake went, hit me up for mathematical miscalculation in just a bit. All right, excess reactant. If one substance runs out, that's the limiting reactant. The other must be left over. That's called excess. This is done on purpose to make sure we use all of the expensive reactant. So if I have a reaction that has poop and gold in it, I would want to make sure that I have excess poop in there because gold is expensive. It's like $2,000 an ounce, and poop is free. Walk through a yard, you'll step on your dogs pretty easily. So that is why you want to use the cheap stuff and make sure you use all of the expensive stuff. To calculate the excess, 1, find the limiting reactant. Convert the limiting reactant to the excess reactant. This is the mass of the excess actually needed. That's how much you need. That's how much it takes to use up all the limiting reactant. Subtract the needed from given, and that's it. So a reaction container holds 5.77 and 5.77. The following reaction occurs. This was the same one we did before, right? So find the excess reagent. So what we found out before, the limiting reagent was O2. So I'm going to convert limiting reagent into excess reagent, okay? So 5.77. Let me make sure O2 was what I had for my limiting reactant because I was worried about my math. Oh, it is. So 5.77 grams of O2 times, I hate you, grams of O2. I'm going to go into moles of O2, and 32 grams of O2 in a mole times dividing bar. My coefficient, don't lose my 5. 5 moles of O2. I'm actually going to do P4 plus 5 O2 yields P4 O10. And then 1 mole of P4 times 1 mole P4. And then I did that molar mass before, but 30.97 times 4 is 123.88. And then this number will tell us how much we need. So 5.77 divided by 32 divided by 5 times 123.88. I need 4.47 needed. Okay. Remember, I have 5.77 grams of it. So then what am I going to do? I'm going to take, so limiting reaction to excess, and then have minus need equals excess. What do I have? 5.77. What do I need? 4.47. That's my excess. This is what I have minus need. This is my excess. So 5.77 minus second answer is 1.30. There's my excess. All right, another one. In an experiment, 3.25 grams of NH3 are allowed to react with 3.50 grams of O2. The limiting reactant was O2. So we just did a couple limiting reactant problems. So there's my limiting reactant. So again, what am I going to do? Limiting reactant to excess, and that will be how much we need. So let's do it. 3.50 grams of O2 times dividing bar. I hate you, grams of O2. I'm going to go into moles of O2. And, I got to balance it again. Was it 4, 5, 4, 6? That rings a bell. 12 hydrogens, 4 night. Yeah, there we go. 1 mole and 32. Hate you, moles of O2. Now remember, I'm converting it into my excess reactant. My excess reactant is NH3. Moles of NH3. 4 NO3s for every 5 O2s. Times dividing bar. Hate you, moles of NH3. I'm going to go into grams of NH3. 1 mole of NH3, go to the periodic table. 14.01 plus 3.03, 17.04. 3.5 divided by 32 times 4 divided by 5 times 17.04 equals 14.91 grams. And that's what I need. Now let me explain this and go a little slower. I'm given this much. This is my limiting reagent, okay? I'm going to convert it into what I need. I need NH3, okay, the excess. So I cancel grams, boom. I go into moles. Moles are not grams of excess, so I cancel moles. Moles over moles gets me into moles of excess. Get out of moles of excess by canceling it, go into grams of excess. That's it, okay? Now remember, it's have minus need is your excess. What do I have for NH3? Ooh, that doesn't look so good. Let me check my math again. 3.5 divided by 32 times 4 divided by 5 times 17.04 equals 1.491. Welcome to the magical world of decimal points. 1.49 is what I need. I have minus need equals excess. I have 3.25. I need 1.49. So 3.25 minus second answer is 1.76. It's not what I said. 1.76 grams of excess NH3. Stoichiometry and limiting reaction with picture. Same idea, but we're going to count and compare. Write the reaction and pay attention to the coefficients as they help determine how many there are at the end. Okay, so for this, we got N2 and we got H2. N2 are the green ones. H2 are the little ones. A little one. All right. So what happens is, if I write this out, I need 3 and 2. So get rid of 1, 1, 2, 3. Get rid of 1, 1, 2, 3. Excess is big green, so excess is N2. Limiting reactant is H2. Why? Because that's what I had left over, right? And if you look right here, this is my excess that's left over, right? Good. Here's another one. If the white circle is H, black circle is C, and gray circle is O, write the reaction. So this would be white circle is H. 1, 2, 3, 4, 5, 6. So H6, so C2, H6. This is C2, H6. And then the shady circle, gray circle is O, plus O2 yields CO2 plus H2O. Hey, it's combustion reaction, CCO2, H2O. Whenever I see Mickey Mouse, I expect it to be water. And hey, I'm right. Why are both reactants limiting? The reason why they're both limiting is because you ran out of both. Okay. So if I'm doing this, if I were to really balance this equation, it would be 2, it would be 3. Oh man, it's going to be 2 of these, and then that would give me 4 of those, and that would give me 6 of these. And then my oxygens I would need would be 8 plus 6 is 14, so 7. So I'd have 1 every 1, 2, and then I need to cross out 7. 1, 2, 3, 4, 5, 6, 7. So see how it works out with your coefficients. Okay, write the reaction. What is a limiting reactant? So I got oxygen, O2, plus nitrogen, oh, no I don't, plus NO, yields, I still have NO, that's just going to be leftovers. Oops, my screen moved. That's just going to be leftovers. What I'm going to be left with is going to be NO2, right, NO2, and then leftovers, okay? Write the reaction. What is the limiting reactant? So this guy I have left over. I'm all out of O2s. Limiting reactant is O2. Do I need to balance this? It looks like I might. Yes, 2, 2. So that's 2, 4, and that's 2, 4. There you go. All right. We'll stop right there. That'll work. And I will say, toodles. Good work, and I hope you have an excessively happy day. Oh.